Hello and welcome to Mission AI's core Python programming course. Now, I'm going to continue with module 3, right? And in the last video, we looked at strings as a collection. In this video, we're going to look at the list data type. Okay, and what is a collection? Basically, a collection of items of various or the same data type, right? And it could be a sequence or not, and that depends on the individual data type. Like in the case of string, we saw that it is a sequence because order matters. Now the list is Python's equivalent of an array, right? And the important thing to note about lists is that they can contain heterogeneous data types, right? Heterogeneous items. Like for example, you can have int, float, string, another dictionary, another list, a set, and so on, right? And here again, lists are a sequence, which means order matters, right? So if you want to store, if you want to record some activity and the order of that activity matters, then use a list, right? So lists are a very, very powerful data type. So you'll see them used across the board in Python because they can carry heterogeneous items, and also they're very flexible. Now, it's also important to note that lists are mutable, right? You remember I told you strings are immutable, which means their state cannot be altered, which means that once they are created, you cannot change the contents of that particular memory location, right? But lists are different. Like you can change the contents of the list and it'll still point to the same list item in memory, right? So there'll be this memory location that this list is pointing to, and you could fill that up with like different items, and it could be of different data types and so on. You could add items, you could remove items, you can replace, you can change the values, and that's completely possible because lists are mutable, right? So just remember, list, dictionary, set, these are three data types in Python that are mutable. So you won't get an error thrown if you try to change the value of one particular element of the list. And another thing to note is lists can contain duplicate items. There's no requirement that it has to be unique. So the first thing we're going to look at is how to create or initialize a list, right? And in the case of strings, we use double quotes to enclose the string. Now in the case of list, we use box brackets, right? Square brackets. So in this particular case, we are initializing an empty list with no items, right? We're just creating this variable that points to an empty list. And in this case, I'm filling up the list with some items. Like in the case of list underscore 2, there are 4 items, which are integers 1, 2, 3, and 4. And these are all of the same type, so you can call it a homogeneous list, right? Now let's look at another list with heterogeneous items. So you can see the first value is 1, then there is this, then the value 2, then the string is, then the boolean true, then then the float 100.25, and then finally the string list. And if you it will not throw an error when you create it, it will not throw an error when you print it. So basically, it kind of indicates that lists are heterogeneous and you can fill them up with anything that you want, right? Then there's the option of also creating a list from variables. Like for example, if I initialize 3 variables a, b, and c with the values 1, 2, and 3 here, then I can create a list by referring to these variables rather than referring to these end values, right? So I'm creating a list from the 3 numerical values, which are integers a, b, and c, and I'm enclosing them in square brackets. Then, as I mentioned, lists contain they're heterogeneous, right? So they can contain anything, and in this particular case, they contain lists. So in the first item of the list, we have another list with the values 1 and 2. In the second item of the outer list, we have another list with the values 3 and 4, and so on, right? So this is what you call a list of lists. So the outer list is a list of inner lists. And finally, just like you saw the string function had an str constructor, the list data type has a list constructor, right? So if you pass no argument to this, then you get an empty list. If you pass a string to it, then you get a list with multiple individual characters of this string. Like, so basically each character of the string would be a separate element of the list. So what we can do is we can run this code line by line to see how it behaves, right? So let's just take these three things first. Come here, paste it, and I'm going to comment out with control/, these two statements here. So the first one is I'm going to create an empty list, right? So let me run it using control enter. And you can see that the value of list 1 is an empty list with box brackets. Now let me uncomment this second set of statements using control/. Now I'll run the entire cell again using control enter. And you can see that list underscore 2 has been created with 4 items, right? 1, 2, 3, and 4. And these are all heterogeneous, but it doesn't really matter. It contains these 4 items, and that's that. And finally, this is a list with heterogeneous items. That is, all these different data types all in the same list, right? So I'm going to run the cell now, and you can see that a list has been created with all these different values, and it's run just fine. Python has not thrown any error, right? So remember, you can create an empty list. You can create a list by specifying the items by hand. They could all be of the same type or of different types, right? And then we're going to look at cases where we can create a list from variables. We can create a list comprising of multiple other lists, and then we can also use the list constructor. So I'll just copy those next bunch of statements and paste them here. So the first one is to create 3 variables A, B, and C, and then construct a list called list4 using these 3 variables, right? So if I run this now, I can see that list4 contains 3 elements, 1, 2, and 3, which are the values of variables A, B, and C. Moving on to list5 now, you can see that it's a list of lists. Okay, so just remember, the outer list has elements, right? And the elements could be anything. So at position 1, what we refer to as the first position, which is index position 0, there is a list containing the elements 1 and 2. In the second position, that is at index 1, there is a list containing elements 3 and 4. At the third position of the outer list, that is with index 2, there is an inner list with values 5 and 6. So that's the meaning of this. So if I run this cell, now you can see that the outer list is comprised of 3 elements, which are 3 inner lists. Okay. And now finally using the list function as a constructor. I told you a constructor is basically a function that creates an object of a certain class type, right? In this case, the class type is list. So what we're telling Python is, we're going to pass you a bunch of items, like compatible items. You can't just pass anything to the list constructor. You have to pass compatible items, right? And typically it has to be an iterable, which means something that can be iterated over, right? So in this case, I can pass nothing and it would create an empty list. And in the second case, I can pass a string, and then each character in that string would become an element of list 7. So if I run it now, you can see that all the elements of the string, that this space is space a space string, like each of those elements, each of those characters is now an element in list 7, right? And in the previous case, it created an empty list. So what if I were to create a list from an object that isn't an iterable. Let me just show you that. So if I say print list of 7, right? Now 7 is, or let's say 10. Now 10 is an integer. Let's see how Python reacts to this. You can see that it throws an error, right? Saying that int object is not iterable. So basically this is the statement throwing the error, and we need to ensure that whatever we pass to the list is something that can be iterated or looped over, right? So int is not a compatible data type for it. So let me just remove this and run the old function, and you can see that it behaves exactly how we expected. So that's basically the part about initializing lists. So we've seen how to use square brackets. We've seen how to specify items in a list. We've seen how they can either be of the same type or of multiple different types. We've seen how to create lists from variables. We've seen how to nest lists, that is a list of lists. And finally, we've seen how to use the list constructor function, right? Let's move on now to some exercises, right? So the first thing is to create an empty list. So L equals just square brackets with nothing in between. So I can just print L. And if I run it, I have an empty list. Second exercise, create a list with the names of the two most populated countries in the world. And those would be India and China, right? So I'll say L equal to India, China. And I'll print L. So let's run this cell using Control Enter. You can also click on the run button here, but I prefer to use the keyboard shortcut, right? It makes work much faster. So you can see that the list contains two strings, India and China. And as I also told you in the previous video on lists, you can either use single quotes or double quotes to instantiate, like to create a string, right? And we had specified double quotes here, but when Python prints it out with single quotes. And you just need to know that they're equivalent. There's no difference between those two things. Now let's move on to the next exercise. Create three variables with values 7.57, 800 and 0.0045, and now create a list with these three variables. So I'll name these variables A, B and C, right? So A equals 7.57, B equals 800, which is an integer. The first one is a float, and C equals 0.0045, which is also a float. So you have two different data types here and three elements. Now I want to create a list with these three variables. I'm going to say L equal to A, B, C. So I'm creating a new list from variables instead of literal values. Now let me print this list and show you what it contains. There you go. The exact values that we wanted are now in the list. Okay, moving on to the fourth exercise. Create a list containing three lists. So I told you that we can also create a list of lists, or basically nested lists, right? So just need to think of it as a list contains elements. Those elements could be anything. It could be an integer, float, string, or it could be another list. In this case, it is another list, right? So let's say L equal to outer bracket, or actually just to simplify it, let me show you this again. I'll create variables with these inner list items, right? So A, 1, that's the first inner list. So I can just, instead of A, I can call it I1, that's inner list 1. I2 is string B and number 2. I3 is, in square brackets, string C and the number 3. So each of these inner lists has two items, and the outer list will have three elements, which are I1, I2 and I3. I1, I2, I3, right? So I can print L. you can see that you now have a list of lists with these exact items that we wanted. And just remember, you can go to any number of levels, right? So as of now, I'm telling you it's a list of lists. Now, this list in turn could contain another list. So it can just keep nesting any number of levels, and that's completely fine, okay? Now create a list containing individual letters of the word independence. So I'll say S equal to independence, right? That's a string. So now I want to create a list containing individual letters of the string independence. So what do I use here? I use the list constructor. So L equal to list of S, which is our string variable. I could have also passed independence, the string here directly, but I'm just passing the variable instead. So now if I print L, it prints out all these letters. And remember, repetition is allowed. So you'll see E in multiple locations over here. Okay. So these are the exercises on initializing lists. Now let's move on to the next thing, which is lists as a sequence. I have already, so this part if you see, for strings, for lists, and for tuples, sorry, it's very, very similar. Okay, it's almost the exact same thing. The exercises are going to look very familiar to you and you'll think you already done them. You have done them for strings, but now it's time to do them for lists. And the reason these exercises are so similar is because the concept is the exact same, right? Like lists are a sequence. So all your items, the position matters. So each element can be referred to by its index, right? And if you refer to an individual element by its index, it's called indexing. If you want to take out multiple elements from the list, it's called slicing or subsetting. So just remember that for a list with n items, the index runs from 0 to n minus 1. So the first element would have an index 0, the second element would have an index 1, and so on till the last element, which has an index of n minus 1, right? And also remember that lists are mutable. I told you that they can be, you can add new elements, you can remove elements, and you can update or modify existing elements. So let's run this code first so that I explain like how indexing and slicing / subsetting works, and then we can do some exercises. So let's say we have a sequence, right, of 10 elements. It's a list of 10 elements and it contains integers 1 to 10, right? So the first thing is you might want to get the length of this list. That is the number of elements in the list, right? And remember, for all Python collections, you can use the len function to get the number of elements. So len is a built-in function, right? So it's not some method of a list. So you don't say list.len. You just say len of list. Like in this case, it's len of sequence. Sequence is the name of this list variable. So len of seq will give you the length of this list, which is 10 because it has 10 items. And let me just copy the first bunch of elements here and put them here. Okay. So I told you about indexing and slicing, right? So indexing is getting a specific element and slicing is getting a set of like a subset of the entire list. Now I've shown you how to get the length of the list. That is the number of elements. Now the next thing is to get the nth item in the list, right? So I told you the index runs from 0 to n minus 1, where n is the length of the string. In our case, it was 10. So the index would run from 0 to 9. So let me just run these things one by one, and I'll show you what the output is. Right. The first thing is to create this. And I'm just going to comment out the entire thing and run them one by one. So first, I'm creating this list, right? So it's been created. I ran it now using Control Enter. Now I want to get the length of the list. So let me uncomment that line and then run it. Uncomment using Control slash and then comment again using Control slash. So if I run it using Control Enter, or in this case, let me just press the run button, you can see that the length is 10, right? So len of list variable name will give you the length of that list. Now, if I want to get the first item of the list, what is the index of the first item? It's 0, right? So I just need to say list variable name of 0, and of again is in square brackets. And I'm going to print out this value. So if I run this cell now, I get 1, which is the first element in the list, right? Which is here, which is exactly what I was expecting. Now let's say I want to get the 6th item in the list. How do I get that? I have to specify the index, right? And the index of the 6th item is 5, which is 6 minus 1 basically. So now if I say sequence of 5 in box brackets and I print out that value, I should get the 6th element, which is 6, right? This is the 6th element here. Now what if I want to get the last item in the list, right? So I told you the index of the last item is n minus 1, where n is the length of the list. So how do I get the length of the list? It's len of list, right? Len of sequence in this case. And len of sequence minus 1 will give me n minus 1, right? Which is this part. So I've got the calculation to get the index part. And then I have to do sequence of this to get the actual list element, right? At that position, at that index position. So let me run this now. Sorry, I had to add a bracket here. Yeah. So the last item of the list is 10, right? Which is here, which is what we expected. And how does the calculation run? Len of sequence is 10, minus 1 is 9, and sequence of 9 in box brackets will give you the 10th item, which is 10. Now you can see that this is a slightly long way of writing this, right? So instead of that, what I'd rather do is find a shorter way to specify it. So Python also has this thing called negative indexing, right? So where you start, if you specify minus 1, what it does is it gives you the last element. If you specify minus 2, it gives you the second last element, and so on, right? So instead of writing this entire thing here, you can just write sequence of minus 1, and it will give you the same answer as above. So in both cases, you get the last element of the list. Now let's get the second last item of the list, right? So instead of saying sequence of len of sequence minus 2, I'd rather just say sequence of minus 2 in box brackets, and this should give me the second last item, which is 9. So if I run it, I get 9, which is the second last item. So these are what you call indexing operations, right? And so what we saw just now was indexing to retrieve the value of an element at a certain position. Now remember that lists are mutable, so you can also modify the value at a certain position, right? So in this case, I'm changing the first item in the list, that is the item at index 0, to 100, right? And in the second case, I'm changing the last item to 200, which is sequence of minus 1. Remember negative indexing, so minus 1 refers to the last item. So if I copy these and I paste it below, so let me just change the last item to the first item to 100 and the last item to 200, right? And now if I print out the value of the list, you can see that the first item is changed to 100 from 1, and the last item is changed to 200 from 10. So all you need to do is refer to the list uh, item at a certain position and change its value. Now, an important thing to note here is the value has to exist for you to be able to refer to it using indexing, right? Let's say I create an empty list, right? And I want to now uh, make the value of the first element as 100, okay? So I can't just, let me just delete these things for now, right? So we've seen how indexing works, but let me explain another important concept. So I'll say L equal to square brackets with nothing inside. So basically it's an empty list. Now if I say L of 0 equal to 1, right? And then I say print L, one would be tempted to think that I've now inserted the value 1 at the first position, which is index position 0, and it should be fine, right? So let me run this and see what happens. So Python throws an error because when you are referring to an item at a certain position, that item must exist, right? So there are other ways that we'll see further down where you use a method to insert an item into a list, either append it to the end of the list or insert it at a particular position. But modifying a value using indexing is possible only if the item already exists. You cannot insert a new value at the end using this particular method. Okay, so we've looked at indexing. Now let's move on to slicing or subsetting, right? And in a sense, what am I getting? I'm getting a range of elements, right? And that's basically what subsetting is. Now, list of in square brackets m to n basically gives us all items from that list, starting at index position m and stopping at index position n minus 1. Remember, it's inclusive on the left side, non-inclusive on the right side. So the starting thing, which is m, is included, and the ending thing, which is n, is excluded. So it goes from m to n minus 1 index. Okay. So let's copy these particular statements now, and I'll be referring to the same list as above. So let me just run that again in case the value has changed somewhere. Wait, but I had also changed the values here. So let me just also run this. Right, so this is all the subsetting part. So I'm just going to comment it for now, and I'm going to run just these three statements. So if I print sequence, at this point, what do I have? I have 1 to 10, but where I replace the first value with 100 and the last value with 200, right? Okay, so now let's go one by one and start extracting multiple elements rather than just one element, right? Okay, so now what happens if we want the first two items of the list, right? We know that list of m to n will give us elements from index position m to n minus 1. So in this case, if I want the first two elements, I just need to say sequence of 0 colon 2, that is 0 to 2. Okay, so that gives me elements from 0 to 1 index positions. That is the first two elements, right? If I had said 0 to 3, it would have given me elements 0, 1 and 2 at index position 0, 1 and 2. So let's run this first. And you can see that it gives you the first two elements of the list, right? Which are these two. Now, again, Python offers you multiple ways to write things a little more easily, right? Now, specifying 0 on the left side of this slice is a little redundant because I could also specify nothing, and obviously it would still refer to the same thing, right? So I can also do that. So sequence of blank colon 2 basically says the exact same thing as the statement above, which is sequence of 0 to 2, which gives us elements at index positions 0 and 1, which is nothing but the first two items of the list. Sorry. So this is equivalent to this, and basically saying this 0 over here, you don't really need to uh, specify it literally, because it's understood. If you leave it blank also, it's considered as 0. Now let's say I want 3 items with indexes 5, 6 and 7, right? So if I want 5, 6 and 7, then I should specify 5 to 8 in the range, so that 8 is excluded, and I get 5 to 8 minus 1, which is 7. So that's basically what I've done here. Sequence of 5 to 8. Let's run this. And we have the elements at index positions 5, 6 and 7, which means the 6th, 7th and 8th items of the list, which are 6, 7 and 8, right? Over here. Okay. Now, sometimes you want some specific items at the beginning of the list. Sometimes you want something in the middle. And sometimes you want something right at the end, right? So let's say I want everything except the first 3 items, right? So basically, items at index positions 0, 1 and 2 should not be included, and everything else should be included. So what I'm going to then say here is I'm going to start at index position 3 and go right till the end. So on the left side, which is here, if nothing is specified, like in this case, it implicitly means 0, right? On the right side of that colon, if nothing is specified, it means right to the end. So what I'm saying is I want elements of the list sequence starting from index position 3 right to the end. So it's the same as saying I want everything other than the first 3 items of the list. So if I run it now, you can see that these 3 elements, which are the first 3 elements, have been left out, and everything else has been included in this list. Just remember that like running this just returns a new list with these elements. It does not change the original list. Okay. Now, what if I want the entire list? Obviously, I could just mention the list name, right? But I could also say, sorry, 1 minute. I could also say sequence of just colon, right? Because nothing on the left side of that colon means 0. Nothing on the right side of that colon means up until the last element. So sequence of nothing colon nothing basically gives you the entire list. So if I run that, I get the whole list here, which is exactly what I expected. Now, let's say I want to start with the first element, right? That is the element at index position 0. And I want to go up to the 7th element. That is up to index position 6, which means I would specify 7 and 7 would not be included. And I want every second element and not every element, right? So when you say sequence of m to n, you're basically saying I want elements from index m to n minus 1. And if you specify a second colon and then another number, this other number is called the step. Okay, so I want from m to n minus 1 in steps of s, right? So s is the step value. In this case, I'm saying I want every second element. So the step value is 2. And the starting index is 0, and the ending index, which I specify, is 7, which actually means 7 is not included, so it runs till index 6. So that's exactly what I've got, right? So index position 7 not included, and 7 would be this, right? So in all these values, I want every second value, which is basically 100. Then I skip 2, then I get 3, then I skip 4, then I get 5, then I skip 6, and then I get 7. So basically 100, 3, 5, 7 is what I get when I run this particular statement. And it might not seem like, where am I actually going to use this? But sometimes you never know like how people record the values in a list, right? Like there are so many different data capture systems all over the place, and everyone has their own logic for capturing data a certain way, right? Like for example, every alternate element might mean something, and let's say every even element might be the name of some kind of variable, and every odd element might be the value of that variable, right? So you might want like to treat even items separately and odd items separately. So if you start from 0 and go right to the end, you get with a step value of 2, you get the even items. If you start from 1 and go right to the end with a step of 2, you get every odd item. So you can use these in multiple different ways, but just know that there are actually practical applications for these features. And now moving on to the final thing, uh, what happens if you want the list in reverse order, right? Obviously, there is a method that I'll show you later on to do this, because it's obviously a very common operation, right? But if you wanted to do it using indexing or subsetting, then how you would do it is, I told you, specifying nothing on the left and right of the first colon means you are going from beginning to end, right? So you want the entire list reversed. And so we had said that the step value is the number of jumps, but -1 is a special step value, right? And what it's saying is, start from the end, and in jumps of 1, give me the entire list. So basically you get the list in reverse order. Here you can see that this is the reverse order of the original list. Okay, so we more or less covered a lot of the subsetting and slicing operations in this, right? You saw how to select the first n elements of a list, where you can specify 0 to something, or you can even leave out the 0. You've seen how to take elements from the middle of a list, saying like list of m to n, and it gives you all items from index m to n minus 1. You've seen how to get the last n elements of a list, like starting at a certain value right through to the end. You've seen how to get list values in steps of 2 or 3 or 4 or whatever you want. And finally, you've seen how to get the entire list in reverse order using the step value as -1. Now, finally, so what we looked at was a one-dimensional list, right? That is a list containing elementary types like int and float and so on. But I also told you that lists can contain other lists. So then you would use multi-level indexing. So for example, over here, so Z is the name of the list variable, right? The outer list variable. So what does Z of 0 give you? It gives you the element at index position 0. That is basically the first item of the list, right? And what is the first item of the outer list? It's an inner list with values 1 and 2. So if I were to get this list from here, I would say Z of 0, right? Which returns the first list, which is 1, 2. Now, what if I wanted to get the first value of that inner list in the outer list, right? So then I would say Z of 0, which gives me that inner list, and then I say of 0 again, which gives me the first value of that inner list, right? Which is the value at index position 0. So Z of 0, 0, both in separate box brackets, gives me the first item in the inner list. and that inner list is the first item in Z. So you specify it from the left to the right, but you imagine it from the right to the left. So what you're saying is, I am getting the first item of some list, right? And that list is the first item of Z. Similarly, what if I wanted to get the first element of the last list in Z, right? The last list here contains the values 5 and 6. Now, what happens if I want to get the first value of that, which is item 5? So then I would say Z of -1, which gives me the last element of list Z, of 0, which gives me the first element inside that last element. So it might seem confusing, so let's just run it, and I think it'll become a lot more evident. Let me remove this sequence, it's not required anymore. Right? So let me just create the list Z here. I've run it, and we have Z in memory. Now, what's the first element of Z? It's Z of 0, right? Which is a list which contains the values 1 and 2. Now, what if I want to get the first value in this inner list? So then I have to say Z of 0 and then again 0, because this Z of 0 is giving me an inner list. So that inner list's first element is referred to this way, right? So inner list of 0 is basically what I'm saying here. Let me run that, and you get 1, right? Which is the first value of the inner list. Now, what happens if I want the first value of the last element of Z? So the last element of Z is Z of -1 in square brackets, which is an inner list, right? So that inner list of 0 gives me that first element over here, which is 5. So let's run that and see. So a way to make that more evident would be, let me say Z of -1, right? So Z of -1 is 5, 6, which is the last element of Z. Now, if I want the first element inside that of the inner list, I would add a 0, right? Which is this. So I'm saying last element of 0 gives me 5. And finally, what if I want the second item in the second item of Z? The second item of Z is the list 3, 4, and I want the second item inside this list, right? So again, let me just clarify it this way. Z of 1 gives me the, so Z of -1, last element of Z, second of Z. So I'm getting the second element of Z, and then I'm getting the second element of that. So second element of Z is 3, 4, and the second element of that is 4, which is what I'm specifying here. Remember, index starts from 0, so second element has index position 1. Okay, so we've looked at indexing, slicing, subsetting, and we've also seen how to apply that to a list of lists. Okay, so let's do some exercises and you'll get much more clarity. So declare a list that has the items 1, 2, A, B, 3, 4, C, D. Right? Let me just copy this here, and LST is the list variable, and I'll just print LST. Let's run it, and we have the list exactly how we want it. Now we need to find the number of items in the list. I told you for any collection, the len function will give you the number of items in that collection, right? And len is a built-in function, not a method. So you say len of collection. So print len of our collection, which is the list, right? LST. So we know that there are 8 values here. So len of list should give us 8. And that's exactly what we get over here. What is the second item in the list, right? Now, the second item is 2, and basically the second item is at index 1. So let's say print of lst of 1, because in indexing and slicing subsetting we always pass the index value. It's called zero based indexing. So it's correct, we get the second value is 2. What is the third from last item in the list? Now I told you, like, the last item is basically n minus 1, right? Which is where n is the length of the string. Now instead of running that complicated long calculation saying len of list minus 1, Python also gives us negative indexing, which is the last item can be referred to as list of minus 1. Second last would be list of minus 2. And in our case, we want the third from last, so list of minus 3. lst box brackets minus 3. And let me run it. 4, right? If you look here, 4 is the third last item in this list. You have D, which is last, C, which is second last, and 4, which is third last. And that's exactly what we got over here by saying lst of minus 3. Now print out the first 4 items of the list. So I told you, if it's the first 4, now this is obviously, we don't want just one element, we want multiple elements, so it becomes slicing or subsetting, right? And when we're subsetting, we specify a range m to n, where it gives us index values, rather values at indexes m to n minus 1. And if m happens to be 0, then we don't need to specify it at all. So let's say lst of 0 to 4. This is what the first 4 items of the list would be, right? That is 1, 2, A, B, which is exactly what we had specified. And a simpler way of specifying this would be without the 0. So you just say list colon 4, right? Which is the same thing. It's an easier way to write it. Now print out the part of the list from the 4th item to the 7th item included. And remember, I'm not talking about index position here, right? In the question. So 4th item is at which index position? 3. 7th item is at which index position? 6, right? But 6 is included. So we specify 7 in the statement. So we say print lst of third index position, that is the 4th item, to 7th index position, which means the index position 6 is included, which is the 7th item, which is what we want, right? So 3 to 7 would basically give us the 4th item to the 7th item, which is what we were looking for. B34C. 4th item is B, 34C are the next 3 elements. Okay, cool. So let's move on to exercise number 7. Print out the entire list without the first 4 items. So usually our starting point is 0, but we don't want the first 4 items. So we want to start with the 5th item, right? And that is at index position 4. So print lst of 4 to the end. So I leave the last part blank. And if I run this, I get 3, 4, C, D. So the first 4 elements were 1, 2, A, B, which have been excluded, and 3, 4, C, D have been printed out over here. Print out every third item in the list, starting with the first item. Now, since you remember M to N is like specifying the beginning and ending positions of the slice, right? And we could now specify the third parameter inside those box brackets, which is the step, right? Now in this case, we want every third item, so the step value is 3. So lst of, I will not specify anything on the left side because it starts with the first item. I'll not specify anything on the right side because it goes all the way to the last item. And then I'll specify a second colon, and now I'll specify the step value, which is 3. So 1, B, and C. Let me explain that to you. So it starts with the first item. right? Then it leaves out the second and third. Then it jumps to B. Then it leaves out 3 and 4. Then it jumps to C and leaves out D. So that's why you get 1, B and C. Okay, so now we have to print out the list in reverse order. I told you that if we specify the step value as -1, then that's like a special condition, right? So it prints out the entire list in reverse order. So all I need to do is say print lst. Since we want beginning to end, I won't specify any values for m and n. I'll just specify -1 as the step value. And here we have the string in the list in reverse order. Okay. So it says create a list with the following items. And this is obviously a list of lists, right? So I'll just copy these inner values and let me create a list L equal to, in box brackets, these values, right? And these values are nothing but inner lists, like India with 1.25, obviously 1.25 billion being the population, is the first element of the list. China with 1.7 is the second element, and USA with 0.35 is the third element of the list. So what is the first item inside the second item of the list? So in which is the second item of the list? China 1.7, right? This list. And what is the first item inside that? It's just China. So I want to say print L of 1, which is the second item, right? I want the second item retrieved, and inside that I want the first item. So I'll say 0. L of 1, 0, which is China, right? Now, which is the second item inside the last item of the list? So which is the last item? It's USA 0.35. And inside that, the second item is 0.35, right? So how do we access the last item of the list? Negative indexing, right? Just say -1. And within that last item, how do we get the second item? Index position 1. Let's say enter. What did I just do? Oh, sorry. L is the variable here. Yeah, 0.35, right? So you've seen how to retrieve elements within like nested lists, also list of lists. So you specify the outer index first, and then you specify the inner index. So I'm retrieving the second item of the outer list, which is the inner list, right? And then within that inner list, I'm retrieving some value. Now change the last item inside the list, which is at the first position of the outer list, to 100, and change the last item of the outer list to zoo. So using the same thing above, change the first item inside the list, which is at the first position of the outer list. So the list which is at the first position of the outer list is this one, right? And I want to change the first item inside this list to 100, right? So what is the first item inside this list? It's India, and I want to change that value to 100. So I'll say, and remember, now I'm using indexing to access an element, and then I'm assigning that element a new value. So L of 0, which is the first position of the outer list, of 0, which is the first item inside that, equal to 100. Print L. So now that first item inside the first item changed from India to 100. Now change the last item of the outer list to zoo. Now this is a slightly strange request, but just it shows you how Python like allows lists to have heterogeneous values, right? Now what is the last item of the outer list? It's this list, right? USA, 0.35. I want to change, I want to throw out that list and I want to put a string in place of that, right? And string value is zoo. So all I'm doing is L of -1, which is the last item, equal to zoo. And now if I print L, you can see that that entire list, which was at the last position, has been thrown out and a string value is now in that place. So the last item of the outer string is now last item of the outer list is now a string. Does that make sense? So just remember the order in which you're accessing it, right? So first you specify what part of the outer list you want to get, right? And that will give you some inner list. Then you specify which element in that inner list you want. And in this case, we were just saying that we want to change the last element of the outer list outright to a string. So that brings us to the end of the indexing and subsetting part of lists, right? So I hope it's been informative for you. And you can see the parallels between that previous section and the indexing and subsetting for strings. It's almost the same, right? Now let's move on to some methods to manipulate lists, right? When I say methods, so basically you have an object, right, which is of a certain class type. In this case, the class type is list, right? And that object has a value. In this case, all the elements of the list are the value. But in that class type definition, there are also some methods, right, that you can access as part of the object that let you perform certain operations. Like there's no point just storing some values in a string, right, unless you can actually do some processing with it. So these methods are how you do that processing. And you always access these methods as object dot method, right? Remember, this is different from the built-in functions. In the built-in functions, you just say the name of the function and you pass some argument to it. The argument could be an object, value, whatever, right? In the case of methods, you always say variable name dot method name or object value dot method, right? So let's look at these basic. So the first set of methods basically deals with adding items to a list and removing items from a list, right? You remember I told you that using indexing, you can only modify the value of an element in the list. You cannot like insert or delete. So let's say we have a list X, right, with values 1 and 2. Now we already dealt with this built-in function len of X, which gives us the length of the list, which is the number of elements, right? In this case, it's 2. Now what happens if I want to add an element to a list and I want to add it to the end of the list? So that's where I use the append function, okay? And remember, I told you a method is always accessed through the object, right? So X is the object, which is the list. X dot append, so what I'm telling Python is, you have the object X, which is a list, which has the value 1, 2, right? And X is mutable, so I can add values to it. So using the append method, add the value 1 to the end of list X. So from 1 to, it now becomes 1 to 1, right? So I've added 1. Similarly, I tell Python again, add the value 4 to the end of list X using the append method, right? So now from 1 to, it's gone to 1 to 1, and now it's going to 1 to 1, 4, right? So the append is straightforward. You don't need to specify anything. By default, that value gets pushed to the end of the list. Now, what happens if you want to insert a value at a specific position in a list, right? That's when you use the insert method. So the first argument you specify in the insert method is the position. It's the index position at which you want to insert it. And the second argument is the value that you want to insert, right? So now you already have a list whose values are 1, 2, 1, 4. So I want to say x dot insert 0, 5. What does that mean, right? It means in list x, I want to insert at index position 0 the value 5. So I had 1, 2, 1, 4. The previous element at position 0 was 1, but now at position 1 I want to insert, and remember, not change but insert the value 5. So basically when I insert something at a position, everything from that position onwards gets pushed by 1. So 1, 2, 1, 4 gets pushed by 1, and the value 5 comes and sits at index position 0. So the value of the list is now 5, 1, 2, 1, 4, right? Similarly, I'm also telling Python, insert into index position 1 the value 6. Now what is index position 1? It's the second position, right? And we had 1, 2, 1, 4, like from the second position onwards before. Now I'm again saying push all that to the right by 1 and insert the value 6 over there. Okay, so the list is now 5, 6, 1, 2, 1, 4, right? Just remember, if by chance I specified insert at index value 10 the value 6, then Python understands that, okay, there is no index value 10, like the list is not that long. So what I'm going to do is I'm going to add this element to the end of the list. Okay, that's like this edge case for the insert function. Now we've seen how to add an element to the end of the list. That's using the append method, right? We've also seen how to add an element to a specific index position in the list using the insert method. Now what happens if I want to start removing stuff from the list, right? So the first thing we look at is the pop method, right? Now the pop method does two things. It removes the last element in the list and it also returns it. So I can assign that value to a variable. So if I say x dot pop, right, it's not just removing the last element from the variable, it's also returning the last element in the list. So I had my value as 5, 6, 1, 2, 1, 4. If I say pop, then the value 4 gets removed from the end of the list and also returned. So it gets returned in this case to the print function, right? And that prints the value 4. And the list is now 5, 6, 1, 2, 1. Okay. So if you print that, this is the value that you get, right? And if I pop it again, then what is now the last item gets thrown out of the list and returned. So if I print that out, I get the value 1, and now my list is reduced from 5 elements to 4, right? So we've seen one way of removing an element from a list. Another way is using the remove method. So if I say x dot remove 1, it removes the first instance from the beginning, the first instance of the item 1, right? Like I had 5, 6, 1, 2. It removes this 1. And now you only have 5, 6, 2. And if there were 5, 6, 1, 2, 1, it would have removed the first instance of 1, which is here in the middle. Okay, so x dot remove will remove an element from a list. It doesn't return anything, it just removes it and updates the list to its new value without that element. And finally, you have the Dell function, which is basically like delete, right? What you're saying is, in this case, is del of x1. So x of 1 is the second position in that list. which is basically the item at index 1, you're saying delete that, right? And when I say delete that, what happens to the remaining items to the right of it? They all move to the left by 1. So it's not like that position is suddenly empty. It's just that everything gets moved by 1, shifted, right? So del of x of 1 removes the second item of the variable x. The second item was 6 here, right? So it removes that, and now the list remaining is 5 and 2. So we just have 2 items remaining in the list. So we've seen how to append to a list. We've seen how to insert at a specific position. We've seen how to pop an item from a list, which is basically remove it from the end as well as return it. We've seen how to use the remove method to remove a specific item, not at an index position, but a specific item with a specific value, and we remove the first instance of that item. And then we've used the del function to remove an element at a certain position. So let's just run this code, and I think it'll give you a much better idea of like how this entire thing runs. So I'll copy this and I'll paste it in this cell over here, and I'm going to just start commenting it out and then running it bit by bit. Okay, so the first thing is we create this list called x, right? And it has 2 values, 1 and 2. And the first thing we do is we get the length of the list, which is len of x, which is a built-in function. So we don't say x.len because it's not a method, it's a built-in function. So len of x. I run it here and we have the value 2, right? Which is correct. There are 2 elements in the list. Now I want to do 2 things, right? I want to append the value 1 to the end of this, which gives us 1, 2, and 1. And then again, I want to append the value 4, which gives us 1, 2, 1, 4. And then I'll print out the list, right? And here we're actually, like when we're saying x dot append, we're actually changing the original list. So if I run this now, x should be 1, 2, 1, 4, which is what we expect, right? Now what happens is, let me say I want to demonstrate the insert method. So at position 0, at index position 0, I'm inserting 5. So 5 comes right at the first position and everything else gets pushed to the right. And at index position 1, I'm inserting the value 6. So 6 comes in the second position, which is index position 1, and everything else gets pushed to the right. So if I print it now, this is what I have, right? So I inserted 5 first and 6 second, and the original values got pushed to the right. Now I'm looking to remove elements from the list and also return them. And when I say return them, in this case, I could have assigned it to a variable, but in this case, I'm just printing out that value. So the first time I call pop, the last value gets thrown out, which was 4, right? 4 was the last value that gets thrown out. And the second time I call pop, 1 is now the last value, so that gets thrown out. Let me run this. You can see that in this case, 4 is the last value. When I say pop, it returns 4, and the remaining list does not have 4 in here, and now 1 is the last value. So if I call pop again, it returns 1 this time, and there are 4 elements remaining in the list. I can just remember that the pop function, the pop method, throws an error if the list is empty, because literally there's nothing to delete and you're asking it to delete something, so it's inconsistent, right? So it throws an error. Now let's see what happens. So in the first case, we've thrown out the last element of the list. Now we want to throw out a specific item, that is an item with a specific value. So we're saying remove 1, right? So remove the element with the value 1, and not just all elements, but the first instance of the element with the value 1. So if I run this now, you can see that the 1 which was there here is deleted, and we only have 5, 6, and 2 remaining. And now finally what I'm saying is, forget values. I want to delete an element at a certain position. In this case, x of 1, right, which is the second position, which is 6. So I'm deleting an element at this second position, and now I have only 5 and 2 remaining. Let's do some exercises with these methods now. Here we go. Create a list with the items 10, 15, whatever till 30, and how many items, and add element 35 to the end of the list. So let's say these are my list items. I'm just going to copy them. I'll say L equal to open and close square brackets. I'm going to paste these values inside. I'm going to print the length of this string, right? Print len of L. What do I have? I have 5. Now I want to add element 35 to the end of this list. So how do I add to the end of a list? I say append, right? Not print. L dot append 35. And now let me print L. So I initially had 5 elements. Now I have appended 35 to the end of the list. So now the list has 6 elements. So insert the item 12.5 into the second position in the list. So that is here between 10 and 15. So append is to the end of the list. The insert function is at a specific index position. So L dot insert at index position 1. Since we're saying second position, it's index 1 and the value is 12.5, right? And then let me print L. So you can see that between 10 and 15, I've inserted 12.5 and all these other values got pushed to the right. Remove the last item in the list and print it out while doing so. So I could have also done something like last equals L dot pop, right? And L dot pop basically gives me the last element in this list, and it also removes it simultaneously from the list. And then I could have said print last, right? Which is 35. Or I could also just say, I'll just comment these two things, and the way to combine those two things into a statement would be print of L dot pop. And in this particular case, 35 was removed, and now there's just items 10 to 30, and 30 is the last element. So now we've popped that one and 30 was returned. Remove item 25 from the list. So item 25 is here, right? And we want to remove that value from the list. So I'm going to say L dot remove 25, right? And then I'm going to print L. So now there are only 4 items remaining. 30 got popped the last time, 30 and 35. And now we used remove method to remove the value 25. So only these 4 items remain, which are here, right? And now I want to remove the third item from the list. There are 4 items. I want to remove the third one. That means it's index position 2. So in this case, I'll use the Dell function, right? Dell of L of 2, because L of 2 is the third item from the list. I want to remove it, and then let me print what's remaining. There should be 3 items, right? So what was at position 3 got removed, and now we have 3 items remaining. So I hope you've understood how to insert and remove elements from lists. Now let's move on to the next part. There's a whole other bunch of list operations that we can do, right? Like for example, you might want to sort the elements of a list. You might want to reverse the order of a list. I already showed you how to reverse the order using slicing and subsetting using the step value, but there are also methods to do this, right? Another thing you could do is you could like, for example, you could like find the number of times an element occurs in a list. You could find the value, the maximum minimum value, and so on. So let's look at how to do these one by one, right? So there are two functions that kind of deal with reversing a list, right? One is a method which is reverse, right? So I have a string, I have a list which is 1 2 3 4, and the variable is x, right? So I say object dot method, right? So x dot reverse, and in a sense I'm reversing the elements of the list and I'm changing the list while doing so. So what I'm saying is alter x so that the elements are now in reverse order. So if I print out x, I should get 4321, right? Let's run this and see what actually happens. So I created a list with 1 2 3 4. With the reverse method, I'm telling Python to alter the list and change the values and like change the order of the values. And now let's print it out and see what we get. So you get 4321, and I've printed x. So the original list has changed, right? Now there is another built-in function, right? Again, here remember the difference between a built-in function and a method. The method was object.method. Now the built-in function is just the function name and you're passing the object to it. The reversed function basically it reverses the elements of a list, right? It reverses the elements of this object that we're passing to it, and it returns an iterator to it. Now, what is an iterator? We'll see later, but it's basically a way to go over the elements one by one, right? And you can't really access the iterate, like you can't access that output directly. So what you would do is you would pass it to the list function so that, and I told you before, like the list constructor takes any uh, iterator, right, and converts that into a list. So it takes all those values and inserts them into a list. So what we're doing here is with this first reversed of y, we're reversing the values of y and returning an iterator to that reversed set of values, right? And then we're converting that reverse set of values into a list. But y does not get changed, right? Y stays as it is. So y is 1 2 3 4, but reversed of y will return 4 3 2 1. I hope you understand the difference. In this case, we had 1 2 3 4. We said x dot reverse, and x was changed. In this case, we are saying reversed of y, which is the built-in function. We're not saying y dot reverse, and y stays the same basically. So if I run this code here now, you can see that printing out the list containing the reversed values will give me 4321, which is what I expected, right? But y itself is 1 2 3 4, which is the original value. So just remember the difference between the reverse method and the reversed function. If you want to modify the list so that we reverse the values within the list, then use the reverse method. If you just want to do some processing but preserve the original list, use the reversed built-in function and then convert that iterator into a list using the list constructor. Now, the same way in one case we modified the list and in another case we didn't modify the list for reverse, the exact same thing works with sort also, right? So a dot sort will basically change the original list, right? It'll sort it in ascending order. So you can basically you could take some set of, like, I don't think this is the right, I mean, this is not the right example because it's already in sorted order. Let me just change the values and show you, right? So instead of 1, 2, 3, 4, let me say 4, 3, 2, 1, right? I'm going to print A. Then I'm going to do A dot sort. And this is what you call, like, just like we had reversing in place, we have sorting in place. It changes the actual object, right? And now if I print A, it should give me the, so for example, it is 4, 3, 2, 1 to start with here. Then I did A dot sort, right? And it changed the object A itself. And now it gives me 1, 2, 3, 4, which is the value of A. So A has been sorted in place. And the exact same way, uh, reverse had a counterpart which was reversed, which did not change the original object. Sort has a counterpart called sorted, which is a built-in function and does not change the original value. So sorted basically sorts the values of B and returns an iterator to those sorted values, and passing it to the list function will convert it to a list. Again, not the ideal example because we used 1, 2, 3, 4, but let's use 4, 3, 2, 1 in this case to show how it's getting sorted, right? So print B. Now I'm doing this operation where I say sorted of B, which gives me an iterator to the sorted values in ascending order, right? And then creates a list out of it. But B remains unchanged. So if I run it now, I had B which was 4, 3, 2, 1. I did this sorting function using the sorted built-in function. It returned 1, 2, 3, 4. But my original list is still 4, 3, 2, 1, right? So reverse, so list dot reverse and list dot sort change the original list. Reversed of list and sorted of list are built-in functions that do not change the original list. They return some other iterator which contains the list in some other order. Okay. Now this also kind of poses an interesting question. Uh, we know how to sort the list in ascending order, right? Using the sort function. How do you sort it in descending order? So all you need to do in that case is sort it in ascending order and then wrap it up with a reverse function. So then it sorts it in descending order. Let me show you that. So we had, let's say 1, 3, 4, 2, right? We had this list that had the values 1, 3, 4, 2. Now we want to sort it in descending order. So just sorted of B and then list, it would have given me 1, 2, 3, 4, right? Which is, let me not worry about this thing. So if I run this, it'll give me 1, 2, 3, 4, which is good. It's in ascending order, but I want the reverse of that. So then I'll do reversed of sorted of B. So sorted of B will give me ascending order. Reversed of that will give me descending order, but this is still an iterator. So then I need to convert it into a list using the list function. So now if I run this, not enough brackets, I think. 1, 2, 3, 4. Yeah, sorry. Here we go. So in this case, I get the list sorted in descending order. Okay. So this is how you can kind of combine the reversed and sorted function to get the list in descending order. Now let's look at index, right? Index basically, see, if you want to access an item at a certain index, it's very simple. You say list of 1 or list of 2, and it will give you the value of the list at that particular index position. Okay. But what if you want to find at what position is a certain value, right? That's when you use the index function. And if there are multiple copies, it returns the index of the first instance of that value, right? And if it's not present at all, then it throws an error. So in this case, m has 5 values, right? 10, 20, 30, 40, and then 20 again. So if I say index of 20, what I'm asking Python to do is return the index at which you first find the value 20 in this list. And I'm saying m.index. So m is the object, right? Now the first instance of 20 that it encounters is here, which is at index position 1, right? So it returns 1. Now, if I say m.index of 25, you can see in this list that the value 25 does not exist, right? So here it will throw an error, and you need to handle that error using exception handling, like try except, right? There's another way to do it where you can check first if the value exists in the list or not, and if it does exist, then you get the index. Let me run this example and show it to you. So we have 5 values in this list. Index of 20 should return 1 because there are 2 instances of 20. One is at index 1 and one is at index 4, but it will return the first instance, which is index 1. Similarly, if I want the index of value 30, I can say print m.index of 30, and this should return 2, right? Let me just comment out the line that's going to throw an error and run this. So index of 20 gives me 1, which is the second position basically. Index of 30 gives me 2, which is the third position. And the last thing I want to do is show you that this throws an error if this value is not found in the list. So here if I run it, you can see that the first 2 statements ran correctly, but the third statement did not run, saying 25 is not in the list. It threw a value error. So that's basically the index function, right? Now, you might also want to figure out, okay, I have a list of, let's say, all the locations from which my customers are, are present, right? You might want to say how many of them are from Bangalore. And for that, you'd use the count function, right? So count will tell you how many instances of this value are present in the list. Like we have the same list, which is 10, 20, 30, 40, 20. So how many instances of the value 20 are there? There's one over here, one over here. So it returns 2. And how many instances of the value 25 are there? There are none, right? So it returns 0. So let's run this and see. So in this case, the value 20 is there twice, so it returns 2. And the value 25 is there 0 times, so it returns 0. And if, for example, I were to change this last 20 to a 50, now there's only one instance of 20 remaining, right? So the value will get updated accordingly. And remember, these are all methods. So you're saying m.count, m.index, m.sort, m.reverse, and so on. Now the final thing we look at is min and max. Okay, like you can look at these functions as the counterpart or rather always used in the same place as len. So len, min and max are always used and they're built-in functions and they're very important to remember. Now in the same list here, you can see that I'm saying max of m because max is a built-in function. It's not a method, right? Similarly, min is also a built-in function. Now in this list, what is the maximum value? It's 40.5, right? So that's what max returns. And the minimum value is 10, which is what min returns. So if we run this, that's what we get. Let's run this now. Max value 40.5, that's max of m. Min value is 10, which is min of m. Let's do an exercise with these second set of methods. create a list with these values, right? So I'm just going to copy this. I'm going to say L equal to open and close box brackets, and I'm going to put these values in, right? So I'm going to say print of L. So this is the list of values in the order in which we created the list. Now we want to reverse this order without changing the original list. So you remember, L dot reverse would have reversed the list in place and changed the original list, but we don't want to change the original list. So we will use the reversed built-in function. So print of reversed of L, which gives us an iterator, and we want to wrap that in a list constructor, right? So now we have the list in reverse order, but if you print out the original list, it's still the same, right? So that's how you use the reversed function over here. Now I want the same list reversed in place and printed out, right? So the first thing I would do is L dot reverse. Remember, this is a method, and I'm calling this method to change this list permanently and reverse its values. And I'm going to print it out. So this reversed list is now, it's like set in stone, right? So if I just print it out normally, this is what I get. The original values have been reversed. Okay, so now let's create a new list with these other values. I'm going to say L equal to these values, print of L. So I have these values here, right? And you can see that they're in jumbled order. You have 10, 200, 30, 0.4, 500, whatever. So these are all in mixed order. Now print out the values of the list in ascending order without changing the original list. So without changing means straight away use the sorted built-in function. And ascending order means only sorted, right? No using reversed with it. So print sorted of L to get an iterator of the values in ascending order, and then pass that iterator to the list constructor to get these values in ascending order. And to get the values in descending order without changing the original list, all you do is take the above statement, paste it, and add this reversed built-in function in between. So what I'm saying is I'm sorting it in ascending order. I'm then reversing it, so it's now in descending order, and I'm then converting it into a list. So let's print it out here. So we have our original list, which is in jumbled up order. We then have, using sorted, we've got it in ascending order, and then adding reversed to that, we've got it in descending order. And if you print the original list, it's still untouched. It's still got the same mixed order values. Okay. Now sort the list in ascending order in place and then print it out. So the same L, let's sort it in place. So L dot sort, right? It's now sorted. Now you print L and run it. So you can see it's now in ascending order. Now print out the max and min values of the list. And we know that these are built-in functions, not methods. So print max of L, and I'll just print it in the same statement, comma, min of L. So 500 is the maximum value and 0.4 is the minimum value. Now, how many occurrences of the item 200 are in this list, right? So either I can like create a variable and then say variable dot count, or I can just say list dot count. So let me just show you both. So print list dot count 200. This should give you the same answer as what I'm about to show you next. L equal to this print L dot count 200. So you get the same thing either by creating a variable and then saying variable dot count, or you just say list dot count, right? It's the same thing. What is the position of the first occurrence of 200 in this list? Over here you can see that 200 first occurs. So there are three instances where it occurs, right? Second position, fourth position, sixth position. Now second position is the first instance, so that's what's going to get returned from the index function. So print L dot index 200, and it should give you the answer 1, which basically is the second position. Here we go. And now we get to these final bunch of list concepts that are important for you to remember. Let's just, I mean, we've already covered a lot of ground with lists, but it's okay. You don't need to know everything at once. Just keep practicing. And more importantly, the idea is for you to know that these things exist. And while you're writing code, you can be very efficient at Googling what exactly needs to be done so that you can get it done fast. Okay. So this clear method, what it does is there are sometimes you want to just work with one object, right? Like, let's say I want to work with the object X, and like I'll do a lot of processing on X. Sometimes I'll insert, sometimes I'll delete, sometimes whatever. There are times where I might want to just clear out the values of X but preserve that object so that I can continue to use it in further processing. So in this case, x.clear removes all the values from X and then converts X to an empty list, but it preserves it and it's the exact same object as before. Okay, so I'll just show you an example of that. So if I say X is 1.2 and then I say print X, then I clear it and then I print it again. You can see that it had the values 1, 2. Now it has no values. But what happens, I mean, is it the same object, right? So I can also print ID of X. You remember I told you every object, every variable has three main properties, right? It has a value, it has a type, and it has the ID, which is like the memory location. In this case also, let me print ID of X. And you can see that they're both the same value. So X is still the same object. You can clear out all the values from X, but X is still the same object. So that's what the clear function does. Another very, very important function is called the range function. So range, you've already seen it in a sense, kind of with this whole subsetting and slicing. So range of m comma n will basically give you numbers from m to n minus 1, right? And if you want to convert that into a list, just pass it to the list function. So range basically returns an iterator with these values, and passing it to the list function will convert it into an actual list. Now, I also showed you the concept of a step value while doing subsetting and slicing. So range is the same way. So if I say range 1 to 10, it basically gives me an iterator to the integers 1 to 9, right? And then I pass it to the list function and converts it to a list with 9 values from 1 to 9. Now, another way of specifying it is range of 10, right? And in this case, the 0 comma 10 is implicit. So what I'm saying when I say range 10 is basically a range of 0 comma 10, which basically gives me 10 numbers from 0 to 9. And there's a third like alternative, right? Which is specifying the step value. Step value means how many am I every second item or every third item and so on. So if I say range 1 comma 10 comma 2, it means give me integers from 1 to 9 in steps of 2. So basically 1, 3, 5, 7, 9. And if I specify that step as -1, then it basically goes in reverse order. Okay, but remember here that your starting and ending values also have to reflect that reverse order. So if I say 1 to 10 in steps of -1, it's basically like an invalid statement, right? Because if I start going from 1 and I go -1, -1, -1, I'll never reach the value 10. So let me just demonstrate these different statements for the range function. So here we saw that we're going to get the values 1 to 9 because 10 is excluded. If I say range of 10, it's going to give me values from 0 to 9. If I say range from 1 to 10, comma 2, it's going to give me those values in steps of 2 from 1 to 9. And finally, if I say 10, comma 1, which is like the higher value to a low value in steps of -1, it's going to give me the descending list. So let me just run that. And you can see exactly what we spoke about. The first one gives us 1 to 9. The second one gives us 0 to 9. The third one gives us 1, 3, 5, 7, 9 in steps of 2. And the fourth one gives us 10 to 1, but 1 excluded, right? So basically integer 10 to integer 2 in steps of -1. Cool. So we've seen the clear function, the clear method, and we've seen the range function. Now, range is a built-in function. Remember that. It's not a property of any particular list. It's just a built-in function to generate a list or generate an iterator. You remember we had just like a few minutes back, we checked out the index function, right? To tell you what is the index of the first instance of an item, right? Now, that is useful in cases where you want to know the position. There are other cases where you only want to know whether a list contains an item. You don't care where it is, you just care whether it's there or not, right? So that's when you use the in keyword, right? So if I say A is 10 and B is a list with values 1 to 10, then if I say A in B is basically an expression, right? And I'm testing for true or false. Now 10 is present in this list, so this expression returns true, and that's the value that gets printed. So let's experiment with this. So we should get the value true, right? Now what if I change this to 11? Is 11 present in this? No, it's not. So I should ideally get the answer false, which is what we get here. So use the in if you want to just test for presence and you don't care about the position. Now, you remember I told you when we dealt with strings that the way to concatenate strings is by using the plus operator, right? And so if you think about it, like it's pretty funny, like Python's super smart this way, right? So if you give two integers or an integer and a float, then the plus operator will give us the sum of those elements, right? If you give an integer and a string, we spoke about Python being strongly typed, right? Now these are incompatible types, so Python throws an error, which is correct. Now, if you pass string plus string, Python understands that now what I'm supposed to do is concatenate. So it concatenates these two things, right? Now, what happens if I do list plus list? Then what Python does is it concatenates these two lists. So if I say list 1 plus list 2, then all the elements of list 2 are appended to the end of list 1 and a new concatenated list is returned. Okay, but the original lists stay intact. So here, for example, you have m is 1, 2, 3, 4, n is 5, 6, 7, 8. If you say print m plus n, which is the same way you would type it for a numeric variable, same way you type it for a string. In this case, it's the same way you're typing it for a list. Let's see what output we get. I'm also just going to print M and N just to show you that the original lists stay untouched. Okay, we have 1, 2, 3, 4 and 5, 6, 7, 8 in two separate lists. So if I say list 1 plus list 2, I get the concatenation of all these values. Like the values of list 2 are added to the end of list 1 and a new object is returned. The original objects stay untouched as they are. Remember that. Now another thing to do where we want to add the elements of list 2 to the elements of list 1 and actually change list 1 is the extend function, right? So we had these M and N, right? And now let's see how we can use the extend function to add these elements to M. So I have 1, 2, 3, 4 in M, 5, 6, 7, 8 in N. Now if I do M dot extend N, what I'm saying is extend basically uh, it affects object M, right? It changes object M because I'm calling that method on object M. So I'm saying take object M and add these new values to the end of it, and these are the values I'm supplying, which are 5, 6, 7, 8. So let me run this now. You can see that M has actually changed. The object M has changed and now it contains the original M plus the values of N, and those values got added to the end while N stays the same. This is what the extend function does. Now we're going to get to three functions which are like super important. Okay, the join function basically merges, like let's say you have a list of strings, right? In the lesson on strings, I showed you the split function, right? The split function basically took a sentence and it split up that sentence into individual words using space as a separator, right? And what it returned was a list of strings, right? Now let's say I want to recreate a sentence from a list of strings. So that's what I use the join function for. So if I say space dot join and then I pass a list of strings, and these strings are basically words, then what I'm in effect telling Python is, hey, construct a new string for me with these words and add a space between each of these words, right? So if I run this, what do I get, right? I should get this entire thing as one string where these individual words are joined by spaces. And that's exactly what I get, right? Now, if I were to pass a hyphen, then instead of space, hyphen would be the separator. So that's exactly what we're passing here. So this is how we use the join functionality, right? So this string, this list of strings could be anything. This separator could be anything, right? Like let's get creative with it. What if I want to create a paragraph out of a bunch of sentences? So then my list of strings would each contain a sentence. Sentence 1, comma, the next sentence is sentence 2, and the next one is sentence 3. And let's say I want to join these sentences by a full stop. So then I'll get a paragraph, right? Here we go. Sentence 1, full stop, sentence 2, full stop, sentence 3. So string.join, and where you pass a list of strings, is a very important function. Now, the next important thing we're going to look at is enumerate. Okay, so in English, when I use the word enumerate, like what do I typically refer to? I mean like describe in a little more detail. Like tell me everything about it, right? So let's say I have a list with the values 15, 25, 35, and I call enumerate, which is a built-in function, right? I say enumerate of C. What it tells me is, it says, okay, I'll tell you about the list. At position 0, you have the value 15. At position 1, you have the value 25. At index position 2, you have the value 35. That's what enumerate tells me, right? And again, it returns an enumerate object, which is like an iterator, and you need to convert it to a list using the list constructor. So let's run this thing and see. And what it returns when it says at index position 0, you have value 15, it's like a pair, right? Like position value pairs. Let's run this. And you have these pairs, right? These pairs are nothing but tuples. Okay, and tuples are further down in module 3. We'll cover them when we need to, but as of now, just understand that I'm saying it's like a pair. At index position 0, I have value 15. At index position 1, I have value 25. At index position 2, I have value 35. So this is what enumerate tells me. And then there's another thing called the zip function, right? Now the zip function, it's like you're zipping multiple things together, like you're combining them and you're joining them to make sense. So you have these individual elements and you want to form more meaningful pairs. Okay, like in this case, I have a list of students, right? Student number 1, student number 2, student number 3. In this list, I have their marks in the examination, 87, 90, 74, whatever it is, right? So I know that, like, the first, the the values at each corresponding position belong together. Like for example, student number 1's marks are 87.3. Student number 2's marks are 90.5. Student number 3's marks are 74%. So I know that these are like corresponding to each other, right? So the question is, how do I make them into pairs so that these pairs are meaningful? So then I use the zip function. I kind of zip these two lists together, and the corresponding elements from each are clubbed into pairs. And I'm saying pairs because right now there are two lists, but you can use any number of lists, right? So let's run this and see what happens. Again here, zip of A comma B basically returns these pairs where it matches like position element at position 1 here with element at position 1 here, and so on. And then I pass it to the list constructor to make a list out of the whole thing. So let's run this, and here's what you see happening. Student number 1 has these marks, student number 2 has these marks, and student number 3 has these marks. So I'm creating these logical collections of data. So if I were to do it for a customer record, for example, right, like a list with all customer names, another list with all customer addresses, another list with all customer, uh, let's say, account type, and fourth is a list with the amount they've spent in a particular year, right? So if I wanted to get like combined information about each customer, I would run the zip function on those 4 different lists. So then I get like a logically belonging together kind of data for each customer. Now let's run some exercises with this, and I think you'll understand a lot better, right? So create a list with the values 1, 2, 3. So L equal to 1, 2, 3. Remove all the values from the list but preserve the list object. So I showed you the clear function, right? It basically preserves that list object. So let's use a clear function, not clear function, clear method on object L. So you have an empty list. Now create a list with the first 10 non-negative integers. So what I want is integers from 1 to 10, right? And I showed you the range function. So let's say the range function returns an iterator and I want a list, right? So I'll say L equal to list of range starting from 1 and ending at 10, which means I need to specify 11 as the last thing here. So if I print L, now I get a list containing the first 10 non-negative integers. Remember, if I say range m to n, it gives me integers from m to n minus 1. So that's why I've gone 10 plus 1, 11 here. Create a list with integers from 20 to 35. So I'll just print out this list directly. List of range of 20 to 35. So I'm going to specify 36 as the outer value in this range. And here we go. 20 is the starting value, 35 is the ending value. Now check if this list contains this value. Now I don't care where it, I mean, if it is present, I don't care where it's present. I only care that it is present or absent, right? So I'm just going to use the in function, the in operator. I need to check if Tim is in this list. Tim in this list. So this is a list of strings, and I'm just checking if this string is present in this list. So let me say enter, and it's false because Tim is not present in this list. Now I want to print out these concatenated lists without changing either list, right? So I'll say A equal to 1, 2, 3, B equal to 4, 5, 6, and I want to print like the concatenated list without changing the original list. So A plus B is what I want to do. The plus operator joins the values from both these lists without affecting the original lists. So if I print A and I print B, I should have the original values. So A plus B gave me this concatenated list of values, and A is separate and B is separate. Now I want to add the items of this list to the end of this list, right? And I already have these variables here, so I'll just use them. Sorry. I'm going to copy this, paste it here. And now I told you about the extend function, right? Extend basically adds a set of values to the end of an existing list, and it changes the original list. And it's a method, it's not a function. So a.extend b, right? So b remains unchanged, but a changes because we're calling the extend method on it. So I say print a comma b. You can see that a has now been changed and b contains 4, 5, and 6. Okay, create a string of the items of the list joined by hyphen. So I have these different, I have a list of strings and I want to join them all with hyphen as a separator. So I've shown you the join function, right? So hyphen dot join and this particular list of strings. This is what will give me my answer. So each of these separated by the other elements with hyphen. Now return a list of all the items of the list along with their indexes. So you have this list, right? And I want to tell you about what element is at what index position. So I'm enumerating this list. So I need to use the enumerate function here. So L equal to this list. Now I want to enumerate it, right? And enumerate returns like an enumerate object, and I need to convert that into a list using the list constructor. So print list of enumerate of L. So I have enumerated L and I have passed that output to the list constructor. So at position 0, I have ABC. At index position 1, I have DEF. And at index position 2, I have GHI, which is basically what enumerating a list is. Now, the last exercise element for us, create a list student names with these values, create a list exam scores with these values, and create one combined list where you have these pairs of student with score. So I'm going to say student names equal to Jim, Tom, and Sam, right? And I'm going to say exam scores. And here's another thing. Remember, just use meaningful names, right? So that's exactly what we're doing here. 70, 80, 85, right? So we have 3 students and we have 3 of their exam scores. And now we want to create these pairs of student name with student score. So what we're going to do, we're going to zip these lists together and then pass it to the list constructor. So list of zip. And what are the 2 lists that we're passing to zip? Student names and exam scores. So if I run this, you can see that Jim has scored 70, that's one pair. Tom has scored 80, that's another pair. And Sam has scored 85, that's the last pair. Because Jim corresponds to 70, Tom corresponds to 80, Sam corresponds to 85. So that's how the zip function works. So that brings us to the end of the list data type in Python, right? You've seen that it can contain any different number of types in the same list. It's heterogeneous. You can see that order matters. It's a sequence. So you can do indexing operations. You can do slicing and subsetting. You can modify the value of a list because it's mutable. You can have nested lists. You can use the list constructor and so on. We've seen how to add and remove elements from a list using append, pop, uh, del, remove, insert, and so on. We've seen how to modify a list, modify the contents of a list using sort, sorted, reverse, reversed, uh, and count and index and so on. And finally, we've also seen these miscellaneous list operations like concatenating using plus, uh, changing a list and adding elements to it using extend. We've seen how to join a list of strings using a certain separator. And very importantly, we've learned about the enumerate and the zip functions, right? Enumerate basically tells you more about a list, like what is in what position. And zip basically combines multiple lists together. So that brings us to the end of the list collection. And in the next video, we're going to explore tuples. Tuples are very similar to lists. Only thing is they're immutable. So once you create them, you cannot change their value. Okay, so see you in that video.